So this is our last example for 4.1. It's just a little bit more complex, still a word problem. Some of this is, we're going to remember some of the sliding over that we did in our last unit 3, just to see side lengths. So when you're getting this big shape here, or given a big shape, you want to try and break it up into little triangles or big rectangles or small rectangles, something to help us out. It says Justin wants to line the perimeter of his patio with paving stone border. What is the perimeter of his patio? So if we take a look here, we know this length, 10.5, and we know this length, 7. And we know this length, 20 meters. But I guess we need to know, what does the word perimeter actually mean? Perimeter means if you walk all the way along and you count all your steps, or you count how many meters, that gives you the total length if you walked the border. Okay, so we've got a few of them, but we still need to solve for some side lengths, like this side length here, from here to here, this side length from here to here, this diagonal side length, even though we know that the height of this area is 15, and this big long side length. So some things to remember is when you're drawing or making shapes, sometimes you can see if you extend something, it'll carry through. Okay, so we'll get this little triangle up here, and even if I extended this down here, I know this is 15, right? So I know this is 15 plus 7, so this is 22. So I could find this side length, 22 plus whatever's here, right? So I know from this bottom to the top of this rectangle is 22, because we carried over the 7 and the 15. But I need to know what this little length is. So we did a little bit more solving here. Now, I know that this is 20 and this is 10.5, so I can solve for this little part from here to here. So then I have a portion of this triangle up top, which is the pieces I want to solve for. So how do I get this little portion? Well, this is 20 and this is 10.5, so this must be 9.5, because of the fact that 9.5 plus 10.5 gives us 20. Okay, so we have a side length in this little triangle. We have to find the angle. What do you know about the degrees in a whole line? They add up to be 180. So if that's 140, this angle in here is 40 degrees, and this is a right triangle. So we can go about and solve for this side length and this side length, because we have this information here. The only other two side lengths we have left to solve is over on this side. And we have right triangle here, and we know this section is 15 meters. So we have a side length and an angle and a right triangle, so we can solve for the other two unknown side lengths using SOHCAHTOA as well. So once knowing that, I think I have all the outside perimeter covered, so then I would go about and solve for those four sides and go 20 plus 22 plus this unknown plus that unknown plus 10.5 plus 7 plus this side length plus that side length, and we'll have the total perimeter. Okay. Sometimes it's nice to label your unknown sides. Okay. And so they labeled A, and that would have been our 22. We figured it out. B is up here. That's the one that we're going to use that little triangle and SOHCAHTOA to solve. Side length C we solved is 9.5. This is side length D. This was C here, 9.5. And we have E and F over here. So, carrying on with this diagram, like we said before, A, we looked across and that's 15 plus 7, that's 22. And we solve for that angle because it's supplementary. 180 minus 140 gives us 40. Side C, because of the bottom being 20 and that one side being 10.5, we subtracted to get 9.5. So we actually, or what they did, was what we have done so far here. So now we're going to solve for side A. That's a hypotenuse. We have angle 40, so this is adjacent. Adjacent and hypotenuse is cos. So we'll say the cos of 40 is equal to 9.5 over our unknown and find it. So right here, cos is equal to adjacent over hypotenuse. So cos of 40 equals 9.5 over d. Put it over 1, cross multiply, we get cos of 40 times d equals 9.5. We divide by cos of 40, we get a length of 12.4. Okay, so that gives us this right here as 12.4. And then we also have to solve for this other angle over here, or this other side. So this is opposite, and this is adjacent, so that's going to be tan. So the tan of 40 is equal to x over 9.5. And that's right here. Tan of 40 is equal to x over 9.5. When we cross multiply, we get the tan of 40 times 9.5 to give us 8 meters. So going back to our picture, this is 8 meters over here. So we just keep on adding to our perimeter kind of stuff. Our last thing we need to do is to find these two side lengths over here, so then we can just add up our total perimeter. With this triangle, we have angle 62. And we have an opposite side, 15 to that. This is the adjacent side, E, and hypotenuse, F. So we can use sine, opposite over hypotenuse. So the sine of 62 is equal to 15 over F. And then we can also use tan. The tan of 62 is equal to 15 over E. And when we go about to do that, we have that here. The tan of 62 is 15 over E. Put that over 1. We cross multiply. We get 15 is equal to tan of 62 times E. Divide by the tan of 62, so we get 8 for E here. So this is 8 meters on this side as well. And then the last one is sine of 62 is equal to 15 over F, which is our hypotenuse. When we put this over 1, we cross multiply, we get 15 is equal to sine of 62 times F. We divide by the sine of 62, we get 17. So if we're asked to find the perimeter is this outside walking piece, right? So basically we just have to add it up. So I'm going to just pick a corner to start with. I'm going to pick here. I'm going to go 22 plus 8 is 30, plus 12.4 is 42.4, plus 7 is 49.4, plus 8 is 57.4, plus 17 is 67, 74, plus 20 is 94.4. Okay, I would write it down, and I'm quite sure they did here. 20 plus 22 plus 8 plus 12.4 plus, oh, I missed this 10.5 when I was counting, plus 7 plus 8 plus 17. Once you put it all in, you get about 104.9. So try some of these harder built kind of pictures where you might have to extend lines to come up with shapes and stuff like that. That will make triangles, because that's how we know how to solve things. We have triangles and other side lengths to help us figure out these things. Once you're done your Build Your Skilled, there's going to be some practice on your own section. So good luck with that. Then you'll have bell work at the very end.